Okay, this is some more of the practice test for the mid-chapter 3 practice test. And number 7, this was a particle motion problem, and a particle moves along a line, so that's position at t is greater than 0 is given by the function negative 16t squared plus 60t plus 100. And first of all, we want to find the displacement in the first 5 seconds. Okay, in the first 5 seconds, so that means my interval would be 0 seconds to 5 seconds. So my displacement's just going to be s of 5. I'll write this up here so you can see here. So my displacement's just going to be s of 5 minus s of 0. And s of 5, that's going to be negative 16 times 5 squared plus 60 times 5 plus 100. Minus s of 0, and s of 0, if I put 0 in here, that's just going to be 100. So hopefully you can multiply these hundreds cancel. So we have negative 16, and 5 squared is 25, plus 60 times 5, 30, that's 300. And again, these hundreds just cancel. So that's going to be the same thing. This is going to be negative 400 plus 300 is equal to negative 100, and that would be feet. So my displacement is going to be 100 feet to the left. All right? So that's pretty much straightforward. I hope that's okay. So that's your displacement. S of 5, this is over the interval, so it's just s of 5 minus s of 0. All right? So it's negative 100. Okay? And this looks like this is the interval AB. This looks like this is s of A. S of B, pardon me, minus S of A. And that was the A part of that problem. Okay, the B part. Okay, find the average velocity during the first 5 seconds. Well, we actually already did part of it, so you can save a little bit of time. The average velocity, that's going to be over this interval, or the average velocity over the interval AB. The average velocity, or the average rate of change, equals f of b minus f of a all over b minus a, so that's just going to be s of b minus s of a all over b minus a. And this is just going to be, s of 5 minus s of 0 all over 5 minus 0. Well, we already computed this up here. This over my interval, I should say 0, 5. But we already computed the s of 5 minus s of 0. We already computed that up here. So that was negative 100. So we have negative 100 all over 5 minus 0, which is just 5. So that's just going to be negative 20. So that was letter B. So we can kind of use the work we did earlier. All right? So that's letter B. That's the average rate of change. Okay. All right, letter C. I'll find the instantaneous velocity when t equals 5. Well, in order to find the instantaneous velocity, remember, and we did a lot of these, section 3-4, the derivative of the position function is equal to the velocity function. That gives us the instantaneous velocity at any time. So if I go back and take the derivative of my position function, that's going to be negative 32t plus 60. So negative 32t plus 60. And we want to find that instantaneous velocity at 5, so that's just going to be v of 5. So that's going to be negative 32 times 5. Get down here so you can see that, pardon me. Negative 32 times 5 plus 60. And that's going to be negative 160. 10 times 320 is 10 times 32 is 320, so 5 times would be half of 320, which is 160. So negative 160 plus 60. So that's going to be negative 100. And that's going to be feet per second, because that's going to be velocity. So that'd be feet per second. Okay, my average rate of change would also be in feet per second, pardon me. Negative 20 feet per second. So make sure you get your units all lined up. So that's letter C. Okay, letter D. Find the acceleration when t equals 5. Well, the acceleration, remember the derivative of the velocity is just the acceleration. So this is my velocity, so the derivative of that's just going to be negative 32. And there's no t, so it doesn't matter what t is. And that's going to be feet per second squared. All right. And the last one, letter E. At what value or values of t does a particle change direction? Well, that's going to be when my velocity is equal to 0. So velocity of t equals 0 when we change direction. So that's going to be, my velocity was negative 32t plus 60 equals 0. So if I subtract 60, I've got negative 32t equals negative 60. So if I divide both sides by negative 32, I get t equals negative 60 over negative 32, which is just 60 over 32. And I can reduce that a little bit, I think, by 4. 4 goes in there 15, and 4 goes in there 8. So that'd be 15/8 seconds. You could leave it like that, or you could say it's the same thing as 1 7/8 second. So that's when it changes direction, because that's when the velocity is 0. All right? Okay, so that's number 7. So that's the E part. And you can always kind of go back and pause it or whatever. So that's number 7.